All right, so today we're going to do something a little different. We're taking the official training material for a course, AURET143 if you're curious, and we're looking past the paperwork. We're not just talking about how to pass a test, we're building the framework for what it really means to be a master at electronic diagnostics. Let's get into it. So imagine this. A car shows up in your bay and the job card is just weird. The driver's window is stuck, the radio's completely dark, and you've got an airbag light glaring at you from the dash. I mean, what on earth do those three things have in common? They seem completely random. Where do you even begin to look? And here's the secret. You don't. You don't treat them as three different problems because they're not. They are all just symptoms of one single root cause, a network failure. And let me tell you, understanding that, well, that changes everything in the world of modern diagnostics. So to really wrap our heads around this, we're going to break it down into 5 core pillars. First, we have to understand the vehicle's network. Then it's all about your safety protocol. After that, we need a solid diagnostic blueprint, followed by true component mastery. And finally, we'll wrap it up with what I like to call the professional finish.
Okay, Pillar 1, mastering the vehicle's network. The first big mental shift you have to make is this. Stop seeing a car as just a bunch of mechanical parts with wires attached. That's old school thinking. A modern car is literally a rolling computer network on wheels.
And you'll mainly run into 2 types of these networks. On one hand, you've got the CAN bus. Think of this as the main data highway of the car. It's high speed, uses 2 wires to make sure the messages get through clearly, and it connects all the really important modules, the brains of the operation. On the other hand, you have the LIN bus. This is more like a quiet little side street. It's slower, uses a single wire, and it's perfect for connecting simpler things like a window switch talking to its motor. And this right here is why that network knowledge is so critical. Say you get one little fault on that CAN bus highway. All of a sudden, Module A just goes dark. So what happens next? Well, Modules B and C were expecting to hear from Module A, and now all they hear is silence. So what do? They both throw up a fault code saying, hey, I can't talk to Module A. And boom, there's our puzzle from the beginning, a whole cascade of codes that look totally unrelated, but they all trace back to that one single network issue. If you're just guessing at this point, you're toast. Okay, once you understand the network, we've got to talk about Pillar 2, and it's a big one, safety. Before you even think about picking up a tool, this has to be front and center in your mind. And listen, these aren't suggestions. These are hard and fast rules you cannot break. The course material actually says it in a way that's, well, pretty chilling, but it's dead-on accurate. Getting this wrong cannot be undone. When we're dealing with systems that can cause serious harm, there are no do-overs. There are no second chances. So let's be crystal clear about the biggest dangers. Number 1, the airbag system, or SRS. These things deploy with literal explosive force. It's lethal. You absolutely must know the correct disarming procedure for that specific vehicle before your hands go anywhere near those components. Second, jewelry. That metal watch or wedding ring on your finger becomes the perfect conductor. It's like a heating element waiting to happen if it bridges a circuit. We're talking severe burns or electrocution. It all comes off. And of course, the basics. Use the right PPE for the job every single time. Now with our safety locked in, we can move on to Pillar 3. Diagnose, don't guess. You know, this is the pillar that really separates the true professionals from the parts fitters. The whole idea is to have a structured, logical game plan before you even think about ordering a new part. And check this out. It's a perfect example. You've got a simple symptom. The door lock doesn't work. Easy, right? Well, the cause could be a super expensive body control module, or it could be a dodgy connector, a shorted actuator, or just a bad ground that's adding too much resistance. If you don't have a plan, you're just throwing parts at it. And guessing costs time, it costs the shop money, and it costs you your reputation. The very first step, always, is a structured test plan. And that plan is built using your whole diagnostic toolbox. You're using a scan tool, sure, but you're not just pulling codes. You're digging into live data streams and waveforms to see what the car is actually doing. You're doing real electrical tests, voltage drops, resistance checks, hunting for opens and shorts. And most importantly, you're arming yourself with information, the manufacturer's wiring diagrams and flowcharts that give you a logical roadmap to find the fault.
So you've got a plan, you've got the tools, awesome. But they're pretty much useless without Pillar 4, component mastery. I mean, think about it. You can't test a system effectively if you don't actually get what the components are supposed to be doing in the first place.
And we're not just talking about 1 or 2 things here. The range of systems you need to know is huge. It's everything from simple power door locks in Windows to really complex stuff like key coding, anti-theft immobilizers, and the entire infotainment, navigation, and passenger comfort setup. A master tech knows how all of it works.
And I don't mean just kind of knowing what these parts do. This is all about precision. It means being able to grab a component, find the ID, and match it exactly to the manufacturer specs. It means you can look at a crazy complex wiring diagram and read it with total accuracy. Because if you misread one wire or misidentify one part, your entire diagnosis can go right out the window.
And that leads us to the final pillar. And honestly, this is the one that separates the good techs from the great ones. Pillar 5, the professional finish. Because let's be real, the job isn't over just because you've bolted on the new part. Once that repair is done, there's a whole process you have to follow. First, you get in there with the scan tool and clear every single trouble code from all the modules. Then, you do your static tests, making sure everything works with the car just sitting there. But you're not done. Now you have to do dynamic tests. Take it for a drive, use it like the customer would, and prove that it works under real operating conditions. And only then do you document everything properly on the job card. So why go through all that extra trouble? Well, for one, it's the only way to be 100% sure that you actually fix the problem. It prevents that dreaded comeback, the customer who shows up an hour later with the same issue. And at the end of the day, it's about professional standards. It's your signature on that job, proving it was done right. So when you put it all together, mastering the network, locking down your safety, having a diagnostic blueprint, achieving component mastery, and always having that professional finish, it really all boils down to one simple question. Are you here to build a career? One defined by expertise and excellence? Or are you just here to fix a car?